Process technology. Unit 13. Environmental aspects of the process industry. Outline. Atmospheric pollution. Sources of atmospheric pollution. Control of emissions to the atmosphere. Water contamination. Water treatment. Primary water treatment. Secondary water treatment. Tertiary water treatment. Noise. Atmospheric pollution. There are many types of atmospheric pollution, and these can be characterized as particulate, solid or liquid; gaseous; vapor. Industrial emissions of major concern are particulate materials, ozone, volatile organic compounds, sulfur oxides, SO2 and SO3, nitrogen oxides, NO and NO2, carbon oxides, CO and CO2. There are four main problems associated with atmospheric emissions. Urban smog, acid rain, ozone layer destruction, greenhouse effect. Urban smog is commonly found in modern cities, especially where air is trapped in a basin. It is observable as a brownish-colored air. The formation of urban smog is through complex photochemical reactions that can be characterized as the interactions of volatile organic compounds, nitrogen oxides and sunlight in the atmosphere, which forms ground-level ozone and other photochemical pollutants. Photochemical pollutants such as ozone, aldehydes and peroxynitrates are formed. Ozone and other photochemical pollutants have harmful effect on living organisms, buildings and structures. High levels of these pollutants can cause breathing difficulties and bring on asthma attacks in humans. In addition to volatile organic compounds and nitrogen oxides, the problem of urban smog is made worse by particulate emissions and carbon monoxide from incomplete combustion of fuel. Acid rain is caused by emissions of sulfur dioxide and nitrogen oxide, which react with water molecules in the atmosphere to produce acids. Problems associated with acid rains include damage to plant life, particularly in forests, acidification of water, leading to dead lakes and streams, loss of aquatic life and possible damage to human water supply, corrosion of buildings, particularly those made of marble and sandstone. Ozone layer destruction. The upper atmosphere contains a layer rich in ozone. Whilst ozone in the lower levels of the atmosphere is harmful, ozone in the upper levels of the atmosphere is essential as it absorbs considerable amount of ultraviolet light that would otherwise reach the Earth's surface. The result of ozone layer destruction is increasing ultraviolet light reaching the Earth, which leads to increasing skin cancer, endangering polar species, danger to plant life, greenhouse effect. Gases such as carbon dioxide, methane and water are present in low concentrations in the Earth's atmosphere. These gases reduce the Earth's emissivity and reflect some of the heat radiated by the Earth. Thus, the effect is to create a blanket, to keep the Earth warmer than it would otherwise be. The problem arises mainly from burning fossil fuels and clearing forests by burning. The result is that global temperatures increase, leading to melting of the polar ice caps, rising sea level, desertification of areas, thawing of permafrost, increasing weather disruptions, changes to ocean currents. Sources of atmospheric pollution. Sources of solid emissions. Incomplete combustion of fuel. Ash from furnaces, boilers and thermal oxidizers. Incomplete combustion in flares. Solids drying operations. Kilns used for high-temperature treatment of solids. Metal manufacture. Crushing and grinding operations for solids. Solids handling operation open to the atmosphere. Sources of gaseous emissions. Combustion producing gaseous emissions. Furnaces, boilers and thermal oxidizers. Gas turbine exhausts. Flares. Process operations where coke needs to be removed. Catalysts, for example regeneration of catalytic cracking catalyst. Gaseous emissions from chemical production. Sulfur oxides from sulfuric acid production. Nitrogen oxides from nitric acid production. Hydrogen chloride from chlorination reactions. Sources of vapor emissions. Condenser vents. Venting of pipes and vessels. Inert gas purging of pipes and vessels. Purges to the atmosphere. Drying operations. Incomplete combustion of fuel in furnaces, boilers and thermal oxidizers. Incomplete combustion in flares. Spillages of volatile organic materials. Open operations such as filtration, mixing, leading to evaporation of volatile organic materials. Drum emptying and filling, leading to evaporation of volatile organic materials. Ventilation of buildings where plants processing volatile organic materials are located. Storage tanks loading and cleaning. Road, rail and barge tank loading and cleaning. Fugitive emissions through gaskets. Fugitive emissions from sewers and effluent treatment. Fugitive emissions from sampling points. Control of emissions to the atmosphere. Control of solid particulate emissions to the atmosphere. The following equipment is used to control of emissions of solid particles to the atmosphere. Gravity settlers. Inertial collectors. Cyclones. Scrubbers. Bag filters. Electrostatic precipitators. Control of volatile organic compounds emissions to the atmosphere. Release limits for volatile organic compounds are set for either specific components, for example benzene, carbon tetrachloride, or as volatile organic compounds for organic compounds with a lower environmental impact and classed together and reported, for example, as toluene. The hierarchy for control of volatile organic compounds emissions is as follows. Elimination or reducing volatile organic compounds emissions at source. Recovery of the volatile organic compounds for reuse. Recovery of the volatile organic compounds for treatment and disposal. Treatment and disposal of the volatile organic compounds laden gas stream. Control of sulfur emissions to the atmosphere. Sources of atmospheric sulfur emissions from the process industries are chemical production, for example, sulfuric acid production, sulfonation reactions. Smelting processes, for example, production of copper. Fuel processing operations, for example, fuel desulfurization. Combustion of fuel, for example, steam generation. Sulfur emissions can be minimized at source through increase in process yield in chemical production. Increase in energy efficiency leading to less fuel burnt. Switch to a fuel with lower sulfur. Desulfurizing the fuel prior to combustion. Control of nitrogen oxides emissions to the atmosphere. Nitrogen forms 8 oxides, but the principal concern is with the two most common ones. Nitric oxide. Nitrogen dioxide. Sources of nitrogen oxides emissions. Chemical production, for example nitric acid production, nitration reactions, etc. Use of nitric acid in metal and mineral processing. Combustion of fuels. Minimization of nitrogen oxides emissions at source means increase in process yield in chemical production. Increase in energy efficiency leading to less fuel burnt. Switch to a fuel with lower nitrogen content. Minimization of nitrogen oxides formation in combustion processes. Control of combustion emissions to the atmosphere. The major emissions from the combustion of fuel are carbon dioxide, sulfur oxides, nitrogen oxides and particulates. The products of combustion are best minimized by making the process efficient in its use of energy through efficient heat recovery and avoiding unnecessary thermal oxidation of waste through minimization of process waste. Flue gas emissions can be minimized at source by increase in energy efficiency at the point of use, for example better heat integration. Increase in energy efficiency of the utility system, for example increased cogeneration. Improvements to combustion processes, for example low nitrogen oxides burners. Changing fuel, for example changing from fuel oil to natural gas. Water contamination. There are two significant reasons why water contamination needs to be considered. The first is that aqueous effluent must comply with environmental regulations before discharge. The concentration of contamination of various contaminants must be less than the regulatory requirements. The second is that contaminant level affects the feasibility of reuse of water. If water is to be reused, then the level of inlet contamination to the operation receiving reused water must be acceptable. Water contaminants that might be specified are organic waste materials. Specifically nominated contaminants, phenol, benzene. Heavy metals, chromium, cobalt, vanadium, etc. Halogenated organic compounds. Organic sulfur and nitrogen. Nitrates. Phosphates. Suspended solids. Water is used for a wide variety of purposes in process operations. Reaction medium, vapor or liquid. Extraction processes. Steam stripping. Steam ejectors for production of vacuum. Equipment washing. Water treatment. Water treatment processes can be classified in order as primary water treatment, pre-treatment, secondary water treatment, biological treatment, tertiary water treatment, polishing treatment. Primary or pre-treatment of wastewater can involve either physical or chemical treatment, depending on the nature of the contamination, and serves three purposes. Allows reuse of water. Recovers useful materials where possible. Prepares the aqueous waste for biological treatment by removing excessive contaminants that inhibit the biological processes in biological treatment. Various water treatment processes are used in the process industry. Solid separation. Methods used for solid separation include most of the commonly used techniques, such as sedimentation, centrifugal separation, filtration. Coalescence. Coalescence by gravity in simple settling devices can be used to separate immiscible liquid-liquid mixtures. Flotation. Flotation can be used to separate solid or immiscible liquid particles from aqueous effluent. Crystallization. If contamination in wastewater has a solubility that varies significantly with temperature, then cooling might allow crystallization of a significant proportion of the contamination. Evaporation. Evaporative crystallization is used to concentrate the contamination as a concentrated waste stream. Membrane processes. Conventional filtration processes can separate particles down to a size of around 10 micrometers. If smaller particles need to be separated, a porous polymer membrane can be used. Microfiltration retains particles down to a size of around 0.05 micrometers. Stripping. Volatile organic compounds and dissolved gases can be stripped from wastewater. The usual arrangement would involve wastewater being fed down through a column with packing or trays and the stripping agent, usually steam or air, fed to the bottom of the column. The volatile organic materials are taken overhead, condensed and, if possible, recycled to the process. If recycling is not possible, then further treatment or disposal is necessary. Liquid-liquid extraction. With liquid-liquid extraction, wastewater containing organic waste is contacted with a solvent, in which the organic waste is more soluble. The waste is then separated from the solvent by evaporation or distillation and the solvent recycled. Adsorption. Adsorption can be used for the removal of organic compounds, including many toxic materials, and heavy metals, especially when complexed with organic compounds. Activated carbon is primarily used as the adsorbent, although synthetic resins are also used. Both fixed and moving beds can be used, but fixed beds of adsorbent are by far the most commonly used arrangement. Ion exchange. Ion exchange is used for selective ion removal, and finds some application in the recovery of specific materials from wastewater, such as heavy metals. As with adsorption processes, regeneration of the medium is necessary. Resins are regenerated chemically, which produces a concentrated waste stream requiring further treatment or disposal. Wet oxidation. In wet oxidation, an aqueous mixture is heated in the liquid phase under pressure, in the presence of air or pure oxygen, which oxidizes the organic material. Chemical oxidation. Chemical oxidation can be used for the oxidation of organic contaminants that are difficult to treat biologically. It can be used to kill microorganisms by oxidation. When used before biological treatment, organic pollutants that are difficult to treat biologically can be oxidized to simpler, less refractory organic compounds. Chemical precipitation. Chemical precipitation followed by solid separation is particularly useful for separating heavy metals. The heavy metals of particular concern in the treatment of wastewaters include cadmium, chromium, copper, lead, mercury, nickel and zinc. In secondary or biological treatment, a concentrated mass of microorganisms is used to break down organic matter into stabilized wastes. The degradable organic matter in the wastewater is used as food by the microorganisms. Tertiary treatment or polishing treatment prepares the aqueous waste for final discharge. Tertiary processes include filtration, ultrafiltration, adsorption, nitrogen and phosphorus removal, disinfection. Noise. Noise can cause a serious nuisance in the neighborhood of a process plant. Care needs to be taken when selecting equipment such as compressors, air cooler fans, natural or forced draft fans for furnaces, and other noisy plants. Excessive noise can also be generated when venting through steam and other relief valve, and from flare stacks. In order to prevent excessive noise from a process plant, noisy equipment should be fitted with silencers. Noisy equipment should, as far as practicable, be sited well away from the site boundary. Earth banks and screens of trees can be used to reduce the noise level perceived outside the site. Revision. List types of emissions to the atmosphere in the process industry. List the main problems associated with atmospheric emissions. What are harmful effects caused by urban smog? What are harmful effects caused by acid rain? What are harmful effects caused by ozone layer destruction? What are harmful effects caused by the greenhouse effect? What equipment is used to control the emissions of solid particles? List water contaminants. Provide a classification of water treatment processes. Describe primary water treatment. Describe secondary water treatment. Describe tertiary water treatment. How water is used in process operations. What are the sources of noise in the process industry? How industrial noise level can be reduced.